All right. I'm going to go ahead and get started. So my talk today is going to be about mainframes. Something that's sort of lacking in the IT security talk conference space. Just to get everyone, because it's the first thing in the morning, I'm going to ask you two questions. First question, when you answer it, I want you to keep your hand up, okay? So how many of you work for, have worked for, or done a security assessment on a mainframe? Right, any of those? Okay. Now keep your hands up. Keep your hands up. Now, how many of you, when you were doing any kind of work for that company, had an account on the mainframe? All right, like maybe half the room. All right, everyone can put their hands down. Next question. What's that? Yeah. How many of you in the last 3 days have used a mainframe? So I'll put my hand up because I was demoing some crap yesterday. But yeah, I was kind of vague. I was being vague on purpose. But everyone's hands should be up because last night for sure credit cards got processed, banking things got processed. If you came here on a plane, definitely your name went through some mainframe on flight information. The government's probably doing some stuff. So they're processing things all the time. It's being used all over the place. So the point was to show that mainframes are being used all the time. So a little bit about me. I'm an IT security analyst. I do work in the IT security space, I guess. I've been doing it for maybe eight years or so. I started out when I was really young. I got into X25 networks in Canada, like DataPack. I don't know if anyone knows what an X25 network is anymore. It was free, and that's why I was into it, because it didn't have to cost me anything. I'm not a mainframe expert by any means. This is just a hobby. It's a weird hobby, I know, but it's my hobby. That's not me, by the way. That's, if you can't tell. So this talk, I'm going to be talking about ZOS. I'm not going to be talking about AS400. I'm not going to be talking about the HP Nonstop. I'm not talking about the BS2000. Yes, that's the name of a mainframe system. I'm going to be talking about basics because I feel like there's a lack of basics in the IT security space, just even mainframe concepts. And then I'm going to talk about some of the security stuff that's going on in the mainframe space. I wanted to make a point here. It kind of doesn't really fit anywhere, but I wanted to put at the very beginning that mainframes are not legacy platforms. Windows NT is a legacy platform. ZOS or ZOS, I'll use it interchangeably. They released a version last year. They release a version every year or so. They release an update. They're up to version 13. Companies update them. They have modern security controls. If you talk to anybody that says, we can't do this because it's legacy, oh, we can't have an 8-character password because it's a legacy system. No, that's not the case. That's not applicable. It's a current operating system, all right? Thing to think about mainframes is they really existed before IT security was a concept. IT security on the mainframe, when it was invented, was a guy with a gun in front of the door to the mainframe room. Okay, that was their IT security. Now, as you got remote logins and as people needed to share time on the mainframe, they started implementing security controls. But they were invented, and all the operating system underpinnings were invented before all that existed. Large companies grew up around mainframes. That's why people are still using them today. So I like to call the site, so what, who cares, right? I just did a search on Monster, Dice, and Google, looking for ZOS and RACF. And I came up with all these, and it's a whole slew of different companies. Food Line, I couldn't find space to fit it in, but Food Line was also there. All kinds of companies, government entities are using mainframes, okay? The reason they still use it is because they spent millions of dollars implementing their mainframes. And then when Windows and Linux sort of started picking up steam, they just built it around the mainframe. It's sort of like a castle. I like that metaphor, and like a medieval castle, and then all the little villages around the castle walls. That's sort of what's going on here. So mainframes really are security through obscurity. Like, how many of you guys know what RACF is, or how many of you guys know, well, you do. And how many of you guys know what like TSO is, or OMBS, or all these weird terms that they throw around? Do you guys even know if you ran an Nmap scan against one, what would you do with that information? Do you know if the open ports are appropriate? Do you know how to run that? You know, there's just things, they're just obscure. People like to think, I think I talked with a gentleman, and he was telling me that, oh, it's that cool big black box in the data center, but we don't touch it. We let the mainframe security guys manage that, but we don't look at it. And they have their own security policies and their own everything. And I was working with a client, and they told me that mainframes are more secure because it's not like Windows and Linux. You can't just go out and buy a $150 computer and start messing around on the mainframe. You just can't do it. That's not true. I'll step down because I want to fall over. So you can emulate the ZOS mainframe in Hercules, and you can emulate it. And IBM actually has a product that does the exact same thing. This is me running, I just like to play around. This is me emulating OS 360 in Hercules. That's the Hercules in the background, and in the foreground is a 3270 emulator that connects. You have no idea how hard it was to change that from the normal one. But so Hercules is currently maintained by a gentleman named Jay Maynard. You may know him better as the Tron guy. Let's see if this is going to work. Let's see if I can do this. There we go. Okay. If you see him, I kind of want him to be known for being the guy who works on Hercules, not for being the Tron guy. Right? So if you see him, say thank you for Hercules, because it's difficult to work with. It's made for mainframe folks, but it's a great tool. IBM has the same thing they call a ZPDT. Now, the IBM one is only for development. You're not even allowed to run production stuff on it. You're not allowed to host data. It's only for development. It's a CD. You throw it in a laptop. It comes with a USB stick with a license on it. You put your license in your computer. You boot it. It boots ZOS, and you're good to go. You need to already have a mainframe to get access to ZPDT. They don't let you, I don't know why, but they don't let you get access to their development environment unless you already own a mainframe. So, I'm going to talk about some mainframe basics. Mainframers speak a totally foreign language. They speak in different terms. It's not that what they're saying is different. They're saying the same things we are. They're just saying it differently. Yeah. So system programmer, administrator. So when if you talk to a mainframe person, they say, oh, he's a system programmer. They're just administrators. IPL, initial program load. That's booting the mainframe. That's you're loading the initial program. It's not rocket science, but they'll use the acronyms for sure. DASD, hard drive. It literally stands for Direct Access Storage Device. LPAR, logical partition. Think of it like a partition. You have like Windows and Linux. That's all it is. Datasets, file. PDS is a partitioned dataset. It's just one file that has multiple entries in it. Virtual machine, USS, OMVS. Vary on and off means enable, disable. But if you speak to someone who's been a mainframer, they will speak in these terms. They won't say partition. They will say LPAR. And if you don't know what LPAR is, and you ask another question, you'll get egg on your face. It's not great. Part of the mainframe is the master console. The master console needs to be secured at all costs. Okay, this is not hyperbole. You can use it to stop services, allow jobs to run, execute jobs with system-level privileges. When you're on the master console, you're not running as a user. You're running as the mainframe. Okay? When you run a command there, the mainframe is going out and just doing it at the machine. It's not referencing the security databases. It's not doing any of that kind of work. All right? You can turn off things like the security. You can just say, you can vary off RACF. You would never do that because that would basically DOS the mainframe, but that's something that could happen. That's why you need to protect it. And you need to protect it because there's no password. When you connect to it, now I'm sure there's going to be some mainframers who come talk to me, and they're going to tell me, well, that's not necessarily true. And they're right. You need to know the port. You need to have the TN3270, and you need to have the master console be waiting for a connection. Some companies have that running, and it's waiting for a connection. So all you need to do, you need to treat it like it needs to be in its own private network, access to this. It should not be on just your normal corporate network. To connect to the OS, to communicate with the OS, it's not that hard. Like I just said, you just need a 3270 emulator, or you can use Telnet or SSH if you want to connect to Unix. The problem with 3270, It was a protocol that IBM developed in the 80s, 90s. It's clear text. Wireshark has no problem following the stream. Wireshark has no problem showing me my password when I log in. IBM identified this. They added SSL certificates so that you could protect against someone sniffing the sessions. Some companies implemented, some companies are still working on it because mainframes are legacy, so they're not working on them. I don't know. Honestly, that's a good question. I don't know if they are, but yeah. Now, I mentioned earlier datasets. A dataset, just a file on a mainframe. It's composed of a high-level qualifier and then other qualifiers. Okay? Easiest way to think of it is the root is the first one. That's the high-level qualifier, and everything after the dot is whatever. So if you have like bsides.password, that's a dataset, and bsides is the high-level qualifier, and password is the file that you're going to look at. If it was bsides.password.hashes, hashes would be the file you're looking at, and then the rest would be the qualifiers to get to it. Okay? The reason it's important to understand that is because files and folders don't exist on a mainframe. They don't call them that, they call them datasets. If you ask a mainframe person, show me this file, they will not even know what you're talking about. They'll say, what are you talking about? You want to see the dataset? When I was getting started with mainframes and I had no idea what was going on, I just said, oh, I just replaced the dot with a slash. That's super easy to understand. Now I get it. TSO is time sharing option. That's generally how people interact with the mainframe day to day. You can add, remove users. You can do networking commands. You can run custom scripts. You can execute jobs. Jobs are, it's like a scripting language, and you write down what you want a program to do, and then you submit it to the mainframe. And the mainframe, depending on your priority and depending on all those variables, it'll then submit it and run it and process it and then return the results to you later. Right? So that's why, so you write a job and it just processes it and gives you the response. TSO is called a segment, and later when I talk about UNIX, it's also a segment. The worst part, TSO logins have a max character length of 7 characters. You can't go larger than that. It's a limit within TSO. But even worse is that on the TSO login panel, you can enumerate users. It tells you at the top there, I don't know if you guys can see, it says user ID Bsides not authorized to TSO. So I wrote a script that uses expect and C3270, which is the console 3270 emulator, to take an IP address and a list of user IDs and to walk through, connect to the mainframe, try it, record the results, and just iterate through that whole file. It's a proof of concept. It's on my site, bit.ly/mainframed. It may or may not work in your environment. It was just to show that it could be done on a test environment. So some interesting commands. This is what TSO looks like. It's red. You can change these colors, but it says ready, and then you just type the command. This is the help command, same as man. You just type help, whatever. I think this is actually a little more elegant than man, because I know man stands for manual, but help, whatever. Help user add, help list. It gives you everything you need to know. There's a bunch of network commands that are built in. I'm not even look. NSLOOKUP, traceroute, and Netstat. Netstat will give you a list of all the open ports that are running on that mainframe. Now this is not the easiest thing to work in. It's so IBM, they have the Interactive System Productivity Facility. It lets you browse, they call it ISPF. No one calls it that, they call it ISPF. It lets you browse and edit files quickly. It allows you to run commands on the mainframe. It's composed of screens, and I have a slide you'll see. And options can be combined because on the mainframes, time is important. So you don't want to waste time waiting for a screen to load. If you know you're going to go 3 screens in, you don't want to have to sit there and wait for each screen to load. You can just daisy chain what screens you want to see. To launch it, you just type ISPF at the prompt. So here's an example. I wanted to search for some files on the mainframe. So I just typed 3.4. So 3, I don't know if you can see it, but 3 on that list is utilities. And 4 on the next screen is dataset list, or DS list. Okay? That brings you to this screen on the left. All I did was put in sys1 as my high-level qualifier, or the root folder I was interested in. And then you hit enter, and it gives you a list on the right of all those data sets that begin with that high-level qualifier. You can go down, and it takes wildcards and all that stuff. And you can see that listing is much better than this. This is the same results if I did the same command at the TSO prompt instead of using ISPF. No one uses this. I mean, rarely anyone does. Unless it's a catastrophic failure and ISPF doesn't work, no one generally uses this interface. They'll use ISPF. It also has a wonderful file editor. TSO comes with a line editor. It does come with an editor, but you have to essentially list the contents of the file, count the line you want to go to, say you want to edit that line, make the change to that line, then save it, and then reprint the whole file again. That's horrible. This is much better. This is so when you're editing a file in the mainframe, you can just use this editor. It's all right. The thing with TN3270 though is you can make all kinds of changes here, but it's not interactive. So as I make changes to the screen, until I hit enter, nothing's going on the mainframe side. So I could edit this whole file and then close the window and lose all my changes because they're not happening on the mainframe. They're happening in my screen until I submit them. UNIX comes with mainframe. It comes as part of ZOS. They don't call it UNIX on the mainframe. If you talk to a mainframe person, they will never say UNIX. They will say OMVS, or they will say USS. USS stands for Unix System Services. It is required if you want to run TCP/IP on your mainframe. If you want to have TCP/IP on your mainframe, you got to run Unix. So therefore, everybody has Unix because I don't think there's many companies that don't want to have TCP/IP access to their mainframe. The worst part, you don't need a password to sudo root. If you're part of a group, there's it's called a class. If you're part of the bpx.superuser class, you don't need to provide a password if you sue up to root in Unix. There's another thing called surrogates, where, for example, if I'm going out of town and I need to run the payroll job, I can let Rogue Clown run the job on my behalf. But she doesn't have permissions to the payroll files, so I say, you have surrogate authority over my account, so you can run that job. One of the side effects is that if she goes into Unix, she can sue to my username without providing the password. Okay? To get access to Unix, you can either do it through SSH or Telnet if it's running, or if you have TSO command, you can just type OMVS. OMVS gives you a shell prompt. Here I just ran uname. Or iShell. iShell is essentially a file browser for the Unix file system that's running on the mainframe. So you can edit the files in there. The same editor as the other one that was running in ISPF. It's just called iShell. You can run TSO commands inside of Unix. So here's an example. On TSO, I just typed time, and it gave me the time. I did the same command on Unix, and it just submits time to TSO, and it returns the results. Okay? Now, and I wanted to mention this at the beginning, but this is a better slide to talk about it. The reason I wanted to give this talk initially was because I feel that there's a gap between IT security, folks who are doing IT security research and releasing tools and generating all that material, and mainframes. And this is a good example of how, what I mean by that. I tried to brute force my login on the mainframe. Like, I know what the username and password is. So I tried to brute force it using THC Hydra and Medusa. Neither of them worked. I mean, both of them just aired out. The first one, this is not a telnet protocol. I literally just telnetted in 5 seconds ago, and it's telling me it's not a telnet protocol. And Medusa wasn't able to identify the login prompt. Nmap fared a little bit better. It was able to at least tell me that I was kind of running a mainframe because I did a service scan. However, there was no OS matches. It couldn't tell me what the OS was. And when I tried to use brute force using the Nmap scripting engine, that also didn't work. It was also unable to identify the login prompt. I wanted to point out here, because I didn't want to have a whole slide dedicated to it. If you see here, BSD-derived Telnet D is running. That's the version of Telnet they're running on the mainframe. It is not vulnerable to the Telnet exploit. When I ran it, I was like, this would be amazing. Like, I'm going to blow up the world. This is great. If that works, of course it's not going to work. It's a different architecture, right? Like, I don't know what I was thinking. So, no, I didn't do anything. It just sat there. I was like, nope, not going to work. So RACF stands for Resource Access Control Facility. Everything that's security related in ZOS is managed in that one database. All access to all the files, all login times, password expiries, everything, including the password hashes. It's all stored in one file. Within RACF, people can be assigned what's known as special attribute. It's not a group, it's like an attribute you give somebody. They don't have administrative access on the mainframe per se, so if you don't give them access to a file, they don't have access to that file. But they have access to change anything they want in the RACF database. So all they need to do is go into the database, change that permission, add them to the list of people who have access to it, and then go back and access that file. Okay? That's why it needs to be limited to only a handful of people. Not many people should have this level of access on the mainframe. RACF is one of 3 main security products that are on the mainframe right now. Top Secret is another one. ACF2 is another one. I know when I talk to people about that, that sounds weird, because security is built into operating systems. It comes as part of the package, right? That's why when I was talking about how mainframes were invented before IT security, that's what I was talking about. They had to add this on top of the operating system. Okay, that's why it's replaceable. That's why you can replace RACF with ACF2 or Top Secret. They do the same thing, they just do it differently. Some companies went with ACF2 because that's what was available at the time, or they acquired a company that was using it. Some companies use Top Secret. Top Secret and ACF2 are both owned by Computer Associates. I don't know why well, it's obvious they have 2 competing products because no one wants to update their mainframes and switch over to one product, right? So they have to maintain both. It's really easy to find where that database is. It can be anywhere on the mainframe. It's not like /etc/shadow. It can just be wherever they want to put it. They call it whatever they want. So if you want to know where it is, you just type the command rvary, and it shows you where it is. Now, each RACF database has a backup. When you make changes to the backup is there for like a hardware failure, not user error. Okay? If I make a change in RACF, it is written to both databases at the same time. But when someone needs access to something, it only reads from the primary. So the idea is to have them on 2 separate hard disks or 2 separate storage arrays. And then that way you'll know if you lose one storage array, you're not going to lose your RACF database and the whole thing's not going to shut down. Access to these 2 files. So if you guys have got a mainframe and you're thinking, oh my God, what? Go take a look at that file. You can type in this command, and then you can go to your mainframe experts and say, who has access to these 2 files? And you want to make sure even read needs to be limited on a need to know. No one should have read access to this unless they're an administrator or an operator. And even then, it's got to be really limited because it stores all of your security settings and the hashes. And I'll talk about why that's important in a bit. The max characters are 8. Someone in here, I was hoping that there'd be like a super mainframe expert in the room who would challenge me on this. IBM implemented passphrases. The minimum for passphrases is 14 characters, and it goes up. I've been auditing mainframes for a while. I have never encountered a company that uses it. Now, I have not gone into the government space, but I'm pretty sure I've never encountered it, just never seen it. The character space is limited to upper lowercase numbers and 3 special characters. That's it. You can set up crazy rules in RACF. You can say, I want the 3rd character to be a number and the 6th character to be a capital consonant. And that's what the user is going to have to use. If you want to look at these settings, you can just type setter ops list. You can't. Only people who have special can run that command, and it'll show you all the password configurations. It'll show you the expiry, it'll show you aging, it'll show you the history settings, it'll show you the limitations, like the 4th character and so on. Yeah? Good question. That's a great segue. So, the hashes, like I said, are stored right in the database. If you go on IBM's website, they say they use a one-way DES hash. That's all they tell you. They don't give any explanations. through some other research, someone published a nice little guide. You can't really see it, but it's on cbttape.org. They published a nice little article about it. What they're really doing is they're taking your user ID, that's the salt. They're taking your password and encrypting your user ID with your password, and then storing that encrypted data, I don't want to say hash, but data, in the RACF database, okay? If the password isn't 8 characters, they pad it with spaces. Bsidic, that's everything in the mainframe is Bsidic. They pad it with hex spaces, right? And then, not hex spaces, they pad it with spaces. Then they XOR it with hex 55, and then they shift it 1 bit to the left. I can't take credit for figuring this out. I definitely did not figure this out. While I was trying to figure it out, I was emailing Nigel Penland, who had already figured it out, and I was trying to figure it out. I'm like, oh, I want to figure this out, and he just emailed me and said, here, this is what happens. I was like, oh, all right, great. So let's take an example of 8 A's, okay? So 8 A's, A in Bsidic is C1, or this in binary. You XOR it with 55. You shift it 1 bit to the left. Now your des key that you're going to use to encrypt the username is hex 28. That's all they're doing. So once that was figured out, I was working with, and Nigel was working with him as well, with a gentleman by Diro Colia. He wrote a plugin to John to take that encrypted value and crack it. If you give it a list of usernames, right? Just using John. You guys know how to use John. The difficult part was getting the data out of the RACF database. But he also wrote, with Nigel's help, a file that just strips out the username and the hashes from the RACF database. That's why no one should have access to it that doesn't need access to it. Because if they have read access to it, they can copy it and do this. Same thing as the shadow file, right? Shadow file needs to be limited to people. This needs to be limited to the minimum amount of people. Yeah, go ahead.
In that file, does it store both the user ID and the hash?
Yeah.
Like, associated?
Yep.
Does that mean that cracking it is really just like...
No, because you still need to brute force it because you don't know the password. Like, you don't know the key, right? And that's what we're trying to figure out is the key, because we know what the unencrypted value is. But so Nigel also released a tool. It's not the same. So John is used for just straight up cracking passwords. RACF Snow, he released it in April. It is used to obviously crack the hashes, but it was more designed for areas that want to test that people are following the password policies and not creating weak passwords. So he has options to say, don't show me the full password. Just show me the first 4 characters. It's a Windows-only tool. It only works on Windows. It's all in one, though. So you take the RACF database, you set up the ini file to say where the RACF database file is. You click go, and it goes. And then it generates a report like this. Okay? I wanted to give a demo. I'm going to give a demo on what John looks like when we're doing this. My JCL, I have JCL that I wrote up to copy a RACF database, which you can get from this actually points to a GitHub site. I'm going to show you that you need to replace. So when you run that rvary command that I showed you before, you just take that entry, you throw it in the JCL, you change one of the datasets to the 2, because all the JCL is doing is copying a file. Okay, it's nothing crazy special. It just, for whatever reason, you can't just type cp space file name. You have to type this to copy a file. All right. So this is JCL. This is what I was talking about earlier. All you need to do is change the sys1.racfds.backup to whatever your RACF database would be, and then open1.racf copy. That's the word my2 data set. I can't take credit for writing all the JCL. I had some direction from Nigel, but I rewrote it to be a little bit more, to explain a little bit more for people who don't work in mainframe all the time. Once you have a copy that you can just FTP off, you're going to need to connect with FTP. you're going to have to get a binary file transfer. Because when you're FTPing something from the mainframe, it's going to translate it from Bsides to ASCII. And you don't want that, you want the binary file. So just type binary, and then you just get a copy of the file. Right? All this is just to really just copy the hashes. I mean, that's it. Right? It's no different than if you're on a UNIX platform, you're just copying the shadow file. So let me give you guys a quick demo here. It's difficult with the one hand. So set up a little slider. So I downloaded John the Ripper from Git. That's Magnum Jumbo. That's the most current version that's available right now. If you do, let's see here. So this is the program that will extract the usernames and the hashes. So it expects the binary file. So I've already copied the file into this folder. You can see and this is on a test system. It's already 13 megs. These files can get enormously huge, in the 600 to gigs of just usernames, data, and settings. So I have a copy of the RACF database here. I'm going to just extract the hashes. So when you run the command, all it does is output it to screen. I just type it out to that file, and then I just run John on that file. Not the most exciting demo, but it works. There we go. It's already started typing that. Now I could leave it running within this little macro here. I used to have a demo about RACF Snow, and if I have time, I seem to have half an hour left, so, or 20 minutes at least. So I can give a demo of RACF Snow if you guys care. It just runs the same thing. One of the things I thought that would be interesting for me personally to challenge. Yeah, go ahead.
Yeah, you parse are there any tools available that parse that RACF database and find, say, users with special permissions?
So,
give me the interesting pieces of RACF.
yeah. So I cut out some stuff. There's a command on the mainframe that you actually run called the database unload. It doesn't unload the database. They call it that, but it doesn't actually like unload. It doesn't break the system. What it does is it takes all that data that's in that binary file and it spits it out into one huge text file. And it has all these separators and IDs and keys and then my IBM has designed Access database scripts for Access and Excel to strip out all that information and put it into a readable format. They've done this all for us because they've done it for an audit function. If people want to know, like you were saying, if people want to know what permission, who has special, or they want to know who can sue or who has UID 0, you can give a user UID 0 in UNIX. If you wanted that to be if you want to look at that, that's how you would go about getting that information. So one of the challenges, when I got this test environment up, I wanted to see how hard it would be to get Netcat working. Turns out it's not that tough. On the old Netcat 1.1.0. Netcat, I think, is up to like 1.7 or something like that. Impossible. The old one, all I had to do was make a couple of changes and add some if-def statements and added a make statement to make some changes. It works. Everything is an Bsides. So it sort of works, but DD lets you convert that into ASCII. So you can pipe to DD, maybe I'm not saying the command right, but you can pipe to that command and you can convert it. I added a make option. This is an example of it compiling on the mainframe itself. I logged into the Unix environment. I'm actually in OMBS here. So I didn't telnet in, I didn't SSH in, I just logged in through TSO, typed OMBS at the prompt, and then went to my temp folder and compiled Netcat in Unix. The one I made, because I thought that'd be interesting, it has the -T and the -E option enabled. So it has lets you execute files and lets you run stuff. It's also available on my GitHub. I made it available to all because that's why I wanted to do it. You can run it, like I said, you can run it from OMVS. There's me just typing in the command. Or you can run it from the telnet prompt. You can run it in either or. Problem is, like I was saying, when you connect, it comes back with garbage. It doesn't look. The first time I tried this, I was like, well, I guess it doesn't work. I guess I can't use this. I have nothing to talk about. And then I was looking up, I'm like, well, oh, wait a minute. There's probably something going on because when I'm. So then I looked it up, and it turns out last year at DEF CON, one of the capture the flag tests was an Bsides something. You connected and it gave you Bsides data, and a guy showed that you could just pipe it through DB and get the output. Because I was searching, I'm like, well, what am I going to do with this connection, right? Who cares if, oh great, Netcat works, but you can't do anything unless you have a mainframe to connect to it, right? So I did some searching. I was able to find out that you can run it no problem. There's a ton of resources online about mainframes. A lot. Everything is available. IBM makes it all available. The red books are guides. They start from ZOS basics all the way up to installing DB2, to getting HTTP working, into the fine-grained details of how to get all that stuff working, and they provide it all for free. The IBM Info Center is a great resource if you have like a one-off question. It's like just like a giant Microsoft help file. It has all your topics inside, and you can search through it. But it's a great resource if you need to know, hey, how do I change this panel from the default? Oh, you can't. Okay, great. The Hercules mailing lists are also a really good resource. It's full of people who have been living and breathing mainframes their whole life. They're super knowledgeable. There's files in their Yahoo groups, because they use Yahoo groups for the mailing list. There's files in there that are great. They're doing it from more of a historical. They're getting really old operating systems to run. For example, there was a video online of someone running OS, I can't remember, maybe 360, or OS of the VM, or maybe IBM DOS on a Raspberry Pi. Because that guy thought, well, this used to take a whole room like bigger than this to run, and now I can run it on a tiny little $35 computer. And actually, people have actually gotten them running on Android phone. They're just their phone. They can just run on their Android phone, because it's just Linux, so they've gotten Hercules running on their phones. The RACF mailing list is a great resource. If you have a question about RACF, if you don't know anything about RACF, you can go there. You can just, I follow it, I read it. People ask questions all the time, and lots of people ask questions about SSL certs on there. Questions about, hey, if I do this, what's going to be the outcome? Or how come I can't do this? And then they'll tell them, oh, you can't because of this reason, or it's really knowledgeable. IBM, it's not run by IBM, but IBM is on the list. These two books are great resources if you're looking into mainframe security. One is What on Earth is a Mainframe? It's like super tiny. It's not very thick, but it's made for people who don't even know what a mainframe is. You guys don't need it because you just sat through this wonderful presentation. But I would honestly, it's a good book. And then IBM actually released a book called Mainframe Basics for Security Pros. It outlines everything you basically need to do to audit and look at security on a mainframe from a locking it down point of view. There's things you need to look at on the mainframe, and they point out how to get to it, how to look it up, how to run the reports, how to do all that work. It's a great book. It's not very big, but it's a really good resource. All of these and way more links are available on my Tumblr. You can just go to mainframed767.tumblr.com. And I think that's it. Anybody have any questions? Yeah, I got about 10 minutes to go here. Anybody have any questions about mainframes? Yeah.
What hardware were you actually running your tests?
Sorry, the question was, what was I running it on? I was running it on this system. No, you can run it on, it doesn't take much horsepower to run Hercules, especially the really old, like the OS 360s and whatnot. It takes almost nothing to run those. Like CPU load is almost 0. Anybody else? Any other questions? Is that, yeah, probably, yeah. Yeah, I mean, it's just DES, so they could probably do that. I don't know. I think, now I've not taken the time to figure out how to do it, but if they've added DES to the, I think, CL or something in John, yeah, then that's no problem. There are DES crackers that are purpose-built gates that you can make, and then it'll crack it in X amount of time. But the point is, you're just going for bulk. You're not going for one specific user. Any other questions? Yeah.
Anything really interesting or great that you found real life?
Not that I can talk about. No, I mean, these things have been around for forever. And they've had multiple security, multiple security audits a year. Not just, so from a keeping it away from people and that standpoint and like trying to lock it down, it's been locked down. It's been severely locked down in certain areas. In other areas where people never even knew to ask these questions, say for example, I've never seen on an audit script where the RACF database is stored and to make sure who has access to that database. Whereas on a Unix audit script, you will always see, make sure to check the permissions on the shadow file, right? So there are some things that have never been checked before. I have not gone back and redone work to see what I've discovered if it's still applicable, but yeah, it's not that bad. And generally these things are the crown jewels of the company. They're the bee's knees. So they don't want people to get access to it. They don't want people to even know about it, that sort of thing. Any other questions? No? All right. Well, thank you, everyone. I hope you enjoyed it.
Well done. I spent probably about 20 or 30 years working with Mainframe. I learned something new today. So, yeah.
And that's why, I didn't mention this in the presentation, I don't want to deal with my coworkers. One of the reasons I started one of the multiple things was that I asked, Mainframe operator, can you show me what